So this talk is called What a Dev Can Learn from Clickteam Fusion. But it's really, the big idea of this is really what a dev can learn from any other programming model. Fusion is it just happens to be a visual programming language, but there's a lot of ideas to be learned from anywhere. So this talk is going to it's going to start with Fusion, and then it's going to take a huge derail towards just learning from other languages. But I'm going to start by talking about Clickteam Fusion. This is what Justin and I use to make Clash Force and Polyroll, which are the indie games we released recently. Clickteam Fusion is like the latest in a long line of visual programming tools made by this company, Clickteam. And they actually started on the Atari ST. That is a screenshot of that at the top. That's like the very first version of the integrated animation editor, which I'm going to show you Fusion's animation editor. It's like you can see the lineage basically, but it's like they've spent several decades just sort of trying to simplify the process of making a game, like put all of the different tools into one spot. Click and play was the first thing I programmed in, so I'm very nostalgic about all of this, which is why I had to have a history slide. But it's basically like, so it's a visual programming language unlike others. I don't know, has anybody used Unreal blueprints and stuff?
Kind of.
Kind of. You at least know what it is.
Yeah, there were a couple of tutorials that were in Unreal when I was just like, so I just did those tutorials.
Cool. Yeah, so it's got similarities in that on the left side here you have events. So each of these events here triggers some actions, and each of these objects at the top are a different kind of class of object. So like this one is called enemy 3 in this case. And then if it has a check mark, that means there's actions that are going to be performed when the event on the left happens. So at the start of the frame, we're going to destroy this big red enemy here. There's two different views. So this is like a spreadsheet view that shows very clearly the classes of objects at the top, but then there's also this view which looks more like standard programming, like condition at the top and then what happens when the condition is true underneath. So I'm going to go jump into Fusion here, and I'm just going to real quick show the process of making a simple game. So you start with this empty play field in the level editor, and I can create an active object. And the image editor is completely integrated. So I just have to double click on the object and then draw some stuff. I'm making a little spaceship. There's its rockets. We have a launch today for SpaceX, so this seems even more appropriate. Okay, so now that I have that, they have these built-in movements, so I can just pick 8-direction movement to say that I want it to be movable with my arrow keys. So now I have a moving ship, and that was easy because they have these built-in like standard movements. So now I can make an enemy. I'll make it a red circle thing. So I'll name it monster. I'm going to name this one player. I'm going to give monsters some health. So each of these objects can have variables associated with them, kind of like member variables in C#. So now that has a health, I'm going to have it start at 3. And I'm going to make a bullet so that I can shoot him. I'm going to make the bullet blue because this is going to be my player bullet. So I'm leaving this outside because it's not going to be actually in the scene yet. It's going to be spawned. So now I'm going to go to the events. So anytime I press space, I'm going to have my ship launch a bullet up. Now that's happening. So I can make the enemy move with like, there's this movement called bouncy ball. So this is just a simple thing that just makes it go in a direction. So I'll move it back in so you can see. So again, it's one of these built-in things that you can sort of compose with other behavior to get more interesting gameplay stuff. They're kind of giving you building blocks, basically. So now I'm gonna make a bullet take health off the enemy. So when bullet collides with an enemy, I'm gonna subtract 1 from the enemy's health. And then when the enemy's health is equal to 0, I'm gonna destroy the enemy. And I guess when the bullet hits the enemy, I should make the bullet blow up too. So now if I shoot it 3 times, it dies. So I feel like I probably can go pretty fast over how events work, but let me just explain this real quick. So events are a concept that is not unique to Fusion at all, but the idea is behavior is triggered by some outside event rather than like you just have a list of statements that run in order or something. Events kind of make things happen on a timeline. Like it's good to think about events as a stream of things happening, and that's gonna come into play a little bit more later. But like I may have an event handler attached to start and clicking button B, but I don't care about clicking button A, so that event on the event stream can get ignored. And then something will happen here. So in Fusion, when the bullet hits an enemy, that's the event. And then these things are the side effects that happen from that event. So connecting this to other languages, events are really like Unity messages. So you're familiar with like start and update, probably. Those are very basic built-in Unity messages. So start happens when a game object in Unity is created. Update happens every frame. And that's exactly the same as in Fusion, like doing something at the start of the frame and doing something on every frame here. These are just like functions, but they're getting invoked from outside by Unity's event loop. And the same thing happens in Unreal blueprints. There's like a begin play event and a tick event, and then you attach things to those to make something happen when those events take place. And in Unity especially, this is very clear, but it's very much like just the generic concept of messages and object-oriented programming. And in fact, like originally when object-oriented programming was first being thought of, they really were thinking of things as individual sort of segmented off objects that could only communicate with each other through events. So in C#, you can just say Mario.jump, and you think of that as a function on Mario. But if you think of it as sending the message called jump to Mario, you can make connections to other very different programming languages. Like Smalltalk is one of the first languages that use this messages concept, like objects communicating with messages. So in Smalltalk, this really reads as send Mario the jump message. And then Mario has an event handler inside it for jump. And in Erlang, kind of a out there language, minimally used, but the idea of Erlang is that you have a bunch of separate processes and they can only communicate with messages. And because everything is a separate process, that gives you a lot of like parallelism in your programming style. I'm not an expert enough to explain all of this, but I mainly want to point out that you can make connections between languages. You can usually find parallels across lots of different languages, and you can use those parallels as a starting off point to use programming styles from one language in another. So back to Fusion. If I've only been working with one object so far, but if I go in and I make more than one enemy, the impressive thing with Fusion, I'm just going to make them all go right so it's not confusing. The impressive thing with Fusion is that all that code I just wrote works for all of them. Like I'm operating on lists of objects in my event code. So if I go in here, it's actually saying if any of my bullets collide with any of the enemies, then I subtract health from the enemy that I hit and I destroy the bullet that hit it. And then this one can be read as for any enemy, if the health is equal to 0, destroy that enemy. So what Fusion is doing is keeping track of lists of objects. So each of these columns in this event sheet view is really like a list of objects, and the check mark means I'm operating on every selected copy of that object in the list. And what these events are doing is filtering that list. So I'm going to show that in a handy diagram here. So in Fusion, I have a list of each type of object. So you can see that over here. I have a bullet, I have monster, and I have player. They're effectively classes of objects because I have multiple monster instances. And when I shoot, I may have multiple bullet instances too. So this sort of shows that I have 2 instances of bullet, 3 instances of monster. Each monster has its own independent health. So in Fusion, if I do, whenever the player presses space, I subtract 1 from health. That's operating on the entire list of monsters because the monster list hasn't been filtered yet. But if I add a filter, like upon pressing space and the ID of monster, so I'm calling the ID of 1, 2, or 3. The ID of monster is 2. Then I subtract 1 from health of that monster. So you can see it's selecting just monster 2 now, and it only subtracts health from that one. And then I can add another event that checks if the health of any monster is equal to 0, I'm going to destroy it. Because this is a new event, the object lists have been reset, like the selection filters have been reset. So now I'm operating on all monsters again. So that's going to destroy just monster 2 because monster 2's health was 0. So you can also apply multiple filters and they stack. So if I say my filter is that the ID of monster is greater than 1, that's going to drop off monster 0 because its ID is 1. And then I can filter the bullet list 2. I can say if the ID of bullet is 2, I want to select that one, and that means only this one is in the filter now. This one got dropped off. I can add another one on top of that to filter the monster list more, to say I'm only going to include monsters whose ID is equal to the ID of the only bullet still in the list. So that's going to say 2 and 2, so it matches these two, and now only these two are selected. So now if I did like an overlap check, it's only going to check for overlap on those two. If monster 1 and bullet 1 were overlapping, it's going to ignore them if I check overlapping. So I filtered out my list so that my overlap check only applies to 2 specific ones. So then I can destroy just those, and only these 2 will be destroyed because I filtered the list. Okay. So the next thing I want to show is qualifiers. Qualifiers are a Fusion feature. But again, there's parallels in other languages. So I'm going to make a boss. Who's going to be a big circle. A very mean circle. Okay, and the boss, I'm going to say the boss has a bouncy ball movement. But I'm going to make a box that he can't escape as a trick to get kind of a very simple boss movement behavior. So this is one of the things Justin did a lot, which I thought was really clever, and I probably wouldn't have thought of if I were working in Unity. But he just, like, since we have bouncy ball movement, if you make bouncy ball movement and then you make a square around it and then make it bounce off the square, like, you've already got a pretty effective boss movement just from that. Like, I would have gone in and tried to write math to do this or something, but like, I can make the square hidden, so no one will ever know that it's just a bouncing ball. And there's other things you can do too, like add little wavy patterns on top of it, like add additional axes of movement, which I'm not going to show, but you can cover up that. And we use that on a lot of the bosses in Polyroll and Clash Force, actually. So now back to qualifiers. So the thing with this guy is he should be hittable just like all of these enemies. So I'm going to give him health. I could go in and I click the button that makes all the UI disappear. So I could go in and copy these events, but what Fusion gives me is a way to basically apply a trait to objects. So I'm going to give both of these the bad trait. And they call them qualifiers, but I'm using traits as a term because it sort of applies more to other languages. So now I can go in and say, I can basically move all of these to the trait. So anytime bullet collides with a bad thing, I'm going to subtract 1 health from the bad thing. And if the health of a bad thing is, I'll zoom in, the health of the bad thing is 0, then we destroy the bad thing. So now I'll be able to shoot the boss too, just like I was shooting the, give it 3 health. So what that did is it put basically a ghost list. So I call it damageable in the slide, but basically anything that my bullets can hit. So damageable acts as sort of another view to the lists. It's its own list that contains other lists. So if I say the ID of damageable equals the ID of the player, say the player was damageable too, then that's filtering the damageable list, but also filtering all of the other object lists that are also damageable. So now, if I were to access a player, that would also be filtered. And if I were to access a monster, the list would be empty because I already filtered damageable. So if I were to, say, count the number of boss object instances, it would say 0 now because I already filtered the damageable list. Okay, so this has a lot of similarities to the entity component system architecture that is becoming somewhat more popular these days. Unity is currently working on a implementation of this, which is kind of in preview right now. But it's basically, if I were to hand wave a lot of details, the idea is that you're working on a list of objects. So you have a list of entities, and you also have lists of components. So each of these is a separate array, basically. Like you have an array of translation components, you have an array of rotation components, you have an array of local to world components, you have an array of renderer components. And then those are, each instance of those components in the array is owned by an entity. So they're sort of decoupling the data from the actual entity object. It's almost like entity is just sort of a handle to an object in the world, and then all of the components that hold data on that object are in separate lists. The key point here for what we're talking about with Fusion is the idea that you're working with lists of things, which is not super standard. So because you're working with lists of things, you can make this outside thing, they call it a system in the entity component architecture. You can make this outside thing that takes in these arrays of these lists of components and then performs some operation on other components. So if I have a system that is converting from local to world space, it would take a translation and a rotation, and then it would apply that to a local to world component. And it can do that in a kind of batch processing type of way, like where it's operating on everything that has these three components on it. So this is like a quick look at what Unity's entity component system does. So you just have components just have data in them. So like this test component just has a fish property, and that's it. And then you have some number of entities in the world. I only had one, but you might have several entities in the world, and each of those has some set of components on it. And then you would have systems that say, I want to operate on components that have these three components on them. A system that operates on entities that have those three components on them. And because the system doesn't care about renderer components, it doesn't even need to grab those, and they just sort of get ignored, even though some of the entities had them. Okay, so another thing that Fusion reminds me of is reactive programming. Like once you're working with events, you can start thinking about what happens when the event is triggered. So probably familiar with model view controller. Basically, model issues a change event, like I notify property changed, or any sort of property changed, just whenever the model changes, it dispatches an event basically, and then you'd have some sort of view that listens to that event and then updates itself. So I don't know, but I imagine the clock in Windows is doing this. Every time the time model changes, the UI listens to that change and updates the time in the UI. So again, you can think of events as a stream of triggers happening. So each time you get a changed event in the stream, it updates the seconds. So this might be 56, this might be 57, 58, 59, and then the next minute. So the next thing to look at is you can sort of propagate these changes across multiple listeners. So if you look at Excel, Excel is probably the world's most popular reactive programming language. It's like I have a source value here, and then in column B, I have this formula that uses the value from column A and adds 1. And then I have another formula in C that looks at the value in column B and multiplies by 2. So every time I update column A, the change propagates forward into columns B and C. So if I change it to 1, this updates, and then if I change it to 2 again, this updates. It's all very instant, and it's triggered by events. Just like in Fusion, when I go in here and I say, there's been a collision between my bullet and an enemy. Like, that is an event that happens exactly when that collision takes place. So exactly when I update this value, the other 2 columns update. And then the next thing you can do from there, this is sort of called functional reactive programming, but there's a lot of different implementations of this that that aren't as pure as that specific term actually applies to. RX is a really popular one for C# that Microsoft wrote. It basically allows you to operate on event streams as if they were lists. So if you've ever seen LINQ in C#, which lets you do filters and transformations on lists, you can do filters and transformations on events with the same kind of concepts, like a map, aka select in C#. You can say, anytime I receive a circle event, I'm going to transform that into a star event. And then you can add an additional filter on top of that event stream to say, I only want to look at star events. So now I have this new stream that only contains green stars. So you can use this to do things like filter out, like look at all the button clicks, but filter out only buttons you care about. You can do that filtering on the event stream itself rather than catching every event and then doing some if check on them. So in Fusion, you can do this kind of programming by adding additional events. So collision between bullet and enemy, but maybe I only want this to work if the enemy's health is greater than 2 or something. And then maybe I would have some other event that handles the case where health is 2, like maybe I'd play a different animation or something. So if it's 3, maybe I would play a different animation here. But I'm actually, you can think of it as actually filtering out the event stream. So I'm only going to run these actions at all if this condition applies to the event that came in here. So basically, to pull this back, Justin and I were working in Fusion for all of our games originally. But we've been trying to get our workflow moved over to Unity because it's easier to do ports in Unity, basically. Fusion is kind of a lockdown system right now, and Unity has a lot of target platforms. So we actually, like as a test, we actually ported a couple of his games from Fusion to Unity, and to support that, I tried to emulate Fusion's programming style in C#. So what I did is I made a event system and an object filtering system that's similar to what you have in Fusion. So you can read this like if a wrecking ball collides with a block, then call block break and destroy the block for every instance of block that was selected by this filter. And because this filter is only including the wrecking ball and the block that collided, that's going to be an object list with length 1. But then this one, like if a block breaker collides with a block, I do an additional filter on top of it to only include block breakers that have this destroy on hit flag set. And then when I do this for each over the block breakers, it's only doing it over the ones that had this filter pass. So I'm kind of combining list filtering and the like if checks together. So I'm only actually executing this if the filtered events pass. And I have custom events too, where I can like filter the custom event stream here on event next spawn picked. That's doing, this is basically returning an event stream of all of the next spawn picked events. And then I can filter that stream with a where to only include events in the stream where next was a piece and not like a power up or something. And then I only apply, like the for each will be done on each of these events. Okay, so I'm gonna flip to C# and actually show some of this. So I basically have a bunch of object lists. They start with Q because we're emulating the word qualifier from Fusion. It's like the break ball qualifier. So I'm basically setting these up to be tied to components, like actually Unity components. So if I go into like pickup, let me do a different one, bomb. So bomb basically just has a remaining fuse time property. And if I go into Unity, and actually show the bomb pickup. It has the fuse time here. So I can put multiple of these components on this and use them to identify it. And then I have these systems like pickup system, which operate on the entire list of objects that have that component on them. So instead of, it's kind of similar to if you did like a game object.find objects of type and then put a component in there, that would give you a list of all the objects. But I'm basically combining that step with only running events if the list is not empty and running an action on every object that has that on it. So I'm effectively able to just transcribe code from Fusion into Unity, which has been really helpful for the porting process. And also, I wanted to show the workflow in Fusion because I think it's pretty efficient. And I've found that sort of pulling all the game logic up into these systems and just being able to type operations to be performed on object lists instead of doing a bunch of for loops and stuff. I found that to be kind of freeing, I guess. It sort of speeds up my programming in a lot of cases because you can just sort of access everything everywhere. So basically, let me show one more thing. So like one of my points here is that you can sort of optimize your workflow. So you can take inspiration from other tools, other IDEs, other level editors, and apply them to what you're using. So like in our case, I tried to emulate a lot of Fusion's workflow in Unity. I'm definitely not there, but I think we're getting there. So one of the things I did is like in Fusion, I can just double click on an object and instantly get the art editor to come up, and I can add frames of animation and all this stuff and just draw on stuff, and it's instantly in the game. So I did a similar thing in here with Sprite. I don't know if anybody's used that, but it's a sprite editing program. So I hooked this up so that it's importing the Sprite files directly. So I can go in here and just like scribble on this sprite, save, and then it's instantly updated in Unity. Well, I didn't do the right animation frame, but scribble. So this progress bar stuff that's going on is like rereading the entire Sprite file and regenerating all of the frames and all of the animations in Unity. So that's just an example of like a non-programming case of this. But so like, I think it's important to look at other tools like Fusion, which maybe a lot of programmers would sort of dismiss as visual programming isn't real programming or something, but a lot of the ideas are applicable and a lot of the workflow is also applicable. And I think the big thing to realize is that you're not stuck with what your programming language gives you out of the box. Lisp is a perfect example. It's basically just lists. Like Lisp is just, it's almost like a format for a programming language without there actually being a programming language yet. And you can just sort of define whatever you want in it. And something to realize is that other languages have similar features. They're just not as obvious. So I'm not gonna like go into Lisp or anything. I figure this talk can be like a set of concepts that can go be researched later, but like C has macros. Other languages have entire languages built on top of them that generate code in the source language. A lot of games will like include a scripting language like Lua in addition to the main language. But another important thing is like C# and other languages that have first-class functions, you can basically do anything in them. Like you can really implement, like you saw what I was doing here, like I'm almost creating a new programming language on top of C#. And you basically have to go learn what own means and learn what on collision list means and what do means. And it almost looks more like a different language. And this is like a key realization I had while I was doing all of this, is that I can sort of mutate C# into another language because C# is so expressive. So here's some other examples of this concept. Like, I feel like ProBuilder is sort of porting 3D modeling software into Unity and allowing you to edit models within Unity. Unreal Blueprints is kind of been ported to Unity through Bolt, which Unity acquired recently. ECS is sort of like you can emulate object-oriented programming style in it. One of the things I like to do is I like to make a base mono behavior that handles cleanup and on destroy, which is exactly like, well, not exactly, but it's pretty close to resource acquisition is initialization patterns in C++ and Rust. Like whenever your game object gets destroyed, it automatically destroys anything that it has ownership of. You can write a wrapper around coroutines that allows you to catch exceptions within them instead of the coroutine just dying. And then you can like emulate a try catch with function calls. You can make a supervisor coroutine wrapper that watches coroutines for failures and then restarts them if they fail. And this guy who makes language X has been working on making C# look like other languages, like look like more functional programming languages. You can add like a maybe type where you kind of get rid of the concept of a null, and you either have a value or you don't have a value, and you can do like simple functions that return you a new object with some property changed, which is helpful for immutable objects. Basically, like if your language is expressive enough, you can implement any other language in it to some extent. And that's kind of my point with all of this. Like you can take ideas from Clickteam Fusion and you can apply them to any other programming language. And I actually did the reverse too. For the Polyroll map screen, I basically wrote myself an extension for Fusion that let me do a call stack and like recursive algorithms in Fusion. So like pushing a bunch of parameters onto the stack and then invoking the same function again in a new stack frame using like a custom extension that maintains that stack inside it. So even in Fusion, you can implement like basically any other algorithm that would be difficult in Fusion this way. So that is the idea. Basically, you can take any programming language and sort of adapt it into your own to get the best ideas from that language. So I think it's important to try other tools. Like Clickteam Fusion is pretty cool. It sort of optimizes the workflow for 2D platformer games. And I feel like the ideas from it are really interesting. And I sort of had my mind opened when I first started working in it again. Okay, I think we're doing questions. Any questions? Okay.
I learned a lot, but I don't know if I have any question. Just today to check the thing. But
yeah,
it's very interesting, and I think.
Yeah, I sort of hoped that it would be a jumping off point for poking around at other stuff. I've been doing a lot of like just general looking at other programming languages enough to get ideas from them and not necessarily fully understand them. But after I realized all of this, I sort of started jumping into other languages, like weird stuff like Erlang and things that people don't really use that much, especially in the game industry. So I think I've got this presentation up on my website, so I can link to that. How do I send messages on this thing? I don't know where the send message button is.
Good question. Chat?
Oh yeah, here it is. And I'll probably open source some of this code at some point. Right now it's like still very much in progress, so I haven't been working on getting it cleaned up to share yet. But all of this like object list filtering stuff, I feel like could be useful for other people. So at some point it'll be on my GitHub. Maybe once Justin and I actually release a game using this, because we haven't yet.
What is own?
Own is part of that resource acquisition is initialization framework I was talking about. So this is in this owner behavior class, which I use as the base for most of my mono behaviors. So if I type own an event stream, that basically puts it in this owned list, and then whenever you destroy the thing, it calls dispose on the event stream, which disconnects all the event listeners when the object is destroyed. So like if I have events attached to a bullet object and I use this own function to subscribe to events on it, when the bullet is destroyed, it automatically cleans that stuff up. So I could also do like, if I had a file handle or something, I could pass in like own of any disposable object, basically. So I could do like own of the file handle. And then whenever this mono behavior gets cleaned up, this file handle would be disposed of too. So C++ does that in like the destructor system. Like if you, well, a better example actually is if you make an object on the stack inside an object in C++, when the object is, like when the object goes out of scope, that will be cleaned up automatically. And you can do the same thing with like unique pointer and stuff. I'm just sort of emulating that feature set in here to give myself some comfort that I don't have to like write a on destroy that cleans everything up, because I might forget something. So if I put own around it, then it's gonna clean it up for me. Just sort of simplifying the code. I think several people have made something like that. But can read about it here. That's kind of what I based it on. Oh, and there's a free version of Fusion if anybody wants to try it. I think you just have a limit on how many events you can make. But I definitely recommend trying it. I think it's just a really interesting tool. Like, I don't know, like watching Justin work in Fusion just kind of opened my mind. Like I think I was overthinking a lot of things.
I think I just tend to underthink things.
Well, it is fast. It's really good at rapid prototyping, I think. I should play bleeping blocks. So this entire game basically is written in this style, like Fusion style event lists everywhere. Actually, I should run it from the top so that I can get the difficulty select. So while I'm in here, I did a couple other things, like I emulated the platform movement of Fusion to, I remember bouncy ball and 8 directions movement. So like even down to the tuning values, I wrote a conversion system that converts from Fusion's units to Unity units so that I could keep everything the same. So like all the inspector parameters are exactly the same values as the values we had in Fusion. I think we tweaked it afterwards, but. Here's bouncy ball. I recreated bouncy ball movement in Unity too. So these are just, I didn't write any code for those. They just get set to bouncy ball movement and then bounce around. I can maybe show the code of bouncy ball. Like it's actually really simple, but I think like what it's doing is pretty obvious. It moves in some direction every frame using typical Unity physics, but it's an interesting idea that if you have something as simple as bouncy ball movement, you can get so many different behaviors out of it, like that boss movement thing I showed in Fusion with the box around it and stuff. Like we made, I think for one of the games, we made an enemy that just walks back and forth, but we did it by making 2 sensors on either side, and it just bounces between the 2 sensors. Something I would have never thought to do. I would have been adding code to check if I'm over ground or something, but it was just so easy to just place a couple sensors. It's that kind of thing. Like Fusion kind of changed the way I program. Anything else you guys want to see? Here's a little bit of the object selection code. It's just these functions called when that do like a filtered list, basically. But obviously this is too much to dig into. At some point I'll post the code. Whale. Seems like a good time to stop to me.
Nice presentation.
Thank you. Thank you for coming.
Thank you for the presentation.
Yeah, I hope it opened your mind.
Yes, it did.
It did.
Thanks everybody for coming. I hope you've had a great siege, and thank you so much, Kevin and Justin, for the presentation. And we will go ahead and end the meeting.
Cool.
Okay, bye.
Thank you. Bye.